Hello everybody and welcome to this process tutorial how to design a water bathroom toy for the shower in Concepts and Shapr3D. With this demonstration, I would like to give all those who are interested in industrial product design kind of like a look behind the scene, how we, together with a client, would, for example, sketch out very quickly initial ideas while we have the talk. So these sketches by nature are only very rough, suggestive, and kind of like block out main features, for example, color, dimensions, functionality, kind of like what you see here. And after the sketch is done, then we will transfer it over to Shapr and then use it as a reference to create a more refined three-dimensional representation. Things will change, dimensions, proportions, etc., because what we sketched out first might actually not really work out once we start modeling. And we will end with a basic prototype, which then could be 3D printed, tested, and then given to the person who would further refine the geometry for manufacturing. The program, again, I use for myself, majority-wise, is Concepts, which is a very affordable sketching illustration program for iPad. You can also use Procreate or Sketch Pro. I personally prefer Concepts because it is vector-based and it gives me the ability to adjust literally everything. So we will start with making a new drawing. I have here just a pen, very basic pen, nothing special. I set up a dimension. I set up a little bit of a curve smoothing. Very good. And again, with this demonstration I would like to show you is how actually the talk or the discussion with a client would come up. So the client has the idea that maybe we would like to have some sort of squarish body, for example, like this. And then at the bottom, instead of being straight, this should be a little bit arced. And you see that the sketches I put down are not necessarily really clean. Again, this is not about drawing nice and clean. This is more really about quickly, while having a discussion, to talk about features. We have, for example, two eyes. At the end, we would like the eyes to spin. There should be water wheels inside. So the center of rotation might be kind of there, and then we can just, with some scribbles, kind of like block out maybe where the eyes would be. This was a tick too big. There, this is better. And let's give this figure a funny look. There can be a mouth at the end there. Okay, so that's kind of like the basic feature. The whole thing from the side might be around 50 millimeters. And the width at the bottom, maybe 80. So it's good when you have a ruler, so you could take measurements, so you have an idea about proportions. There are some sort of extrusions at the sides. We don't really have ears, so I'm doing a scribble here again. Move this a little bit away, and then I use the slice tool and remove half of it. Select everything, and I just move this back. Make a copy, rotate it over, or mirror it over there. And so it looks like a robot, maybe some ant dots. Kind of cool. Okay. So on the top, I know we would like to have liquid to come in. And I'm building another extrusion on top. And so let's put down maybe a small socket. Okay. Somewhere further on top, then we will have a funnel. And yeah, this starts to look kind of like the way it should be. This funnel goes into the socket there. So I'm just suggesting that it is an interlocking mechanism. We could specify this with 20 millimeters till it hits the socket. That should be 15 millimeters. This is maybe 5. This is 5. And maybe, I don't know, we have to see if this will work out. Maybe another 5 millimeter, how all these elements here break out. Okay, so you see the sketching is really fast. No? It's not clean. We use sketching in industrial design for various methods. Well, we can talk about ideas, but as long as we don't have something to see, it's difficult to visualize it. And there are different levels of sketching. You can do a sketching very nice and refined for final presentation. These sketchings take a long time. But like as you can see here, we can also employ sketching simply to block out ideas and not work very precise, but maybe somewhat accurate. The socket here, I would like to be 20 millimeter, and this I think could be 18 millimeter. So we have a water flow out, and the socket, the funnel you see is smaller than the socket. At the bottom, we actually would like to do the opposite. So I will have a small socket. So this should be 18, and then a bigger socket, for example, that comes over. And there should be some sort of maybe a water ball at the bottom that could spin. We need to have some sort of connection there. Maybe sketch this over, okay. And the inside here, that would be the tunnel, and this would spin. Very good. It also really helps to add dimensions, as you can see, but also names. I know what everything is. If somebody takes a look at this, do they really understand what this is? So for example, it's a funnel. This should be a water wheel. There's a mouth, which, however, is open. So actually a little bit of liquid can spill out too. Here we have eyes that actually will rotate. So now we have a front view. Now it's all nice and good. What will make sense then is to try to proportionally maybe block out a side view. So we have this, then here's our little extrusion. You see how I'm bringing this over. So somewhere here will be these earmuffs like things. A smaller socket here at the bottom and a bigger socket here. And yeah, the funnel, do we do this same size or we make this a little bit bigger? Like this, there, very good. And then we can connect this. The lines are a little bit crooked, so I can just select them and start and rotate them a little bit. Or if one side, for example, I really like, let's select this. I select all those, copy and mirror this over, bring this to there, and then I start putting in the other lines. So you see actually how flexible actually concepts here is. There, very nice. And this down here, so the body, I envision 30 and this maybe 40 millimeters. Okay, very good. Adding a little bit of color can help too. I will use kind of like a technique from drawing a cartoon. So I will ink actually the background. I have here a tool. If I double tap it, you see I use a fill tool, and then I will use orange as the color. And now fill actually everything that I think will be orange. I can lower the transparency a little bit so it doesn't really stand out too much. Again, you see, the work is a little bit fast, and this is all good. Something I tell my students very often, it's not about drawing nicely. The biggest, most important question is, well, why do we actually draw? Do we draw because we want to make something look nice? Do we draw because we would like something to explore, to explain? These are all decisions we have to make, and all these decisions will sooner or later actually dictate what type of drawing method we can employ. There, very nice. And I noticed I forgot actually one blue area. There. Cool. Okay. So while having talked with the client likes this. The eyes, for example, should be open. There should be a nice big orange ring maybe around or something. And with the eyes also being white, we would like to give them an iris. Very nice. Very good. So this is the discussion, let's say, pretty much is established. Now we are good. Now the proportions are done. We have basic dimensions. Now we can take a look at, well, is this actually going to work out? And this is another thing I really would like to point out. While I would not think about sketching in terms of drafting very precisely, because once we start 3D modeling, things might change a lot. So what's in the point when we're still in the explorative phase to be that precise? But it is good to have an overall dimension idea. So this way I know that my drawing is not too crazy, too bad. Okay. One very easy way now to bring this over is we simply will make a screenshot. Then I adjust the image size. There we are. Very good. And I will save this to the files and call this water toy sketch. Save. Very good. Now going over to Shapr, we will just start with a new design. And there we are. We want to make sure our units are set to millimeters. All our snapping elements are turned on. I will go to the front view. Very good. And I will bring in the image now. There it is. Okay. We're selecting transform, move. I can move this to the side. Click OK, because what I need to figure out now is actually the size of the sketch. 80 by 50 is one dimension for the main body. So I draw something here and there. So this is 10 by 20, so way too small. So I will set this to 80 and this should be 50. Very good. Now we can see how big this image should be. So our sketch is actually kind of tiny. Since I am sketching here first, let me finish this. I would like the sketch to be perfectly centered. So I can bring this over. Maybe I should select all these lines and first give them the correct vertical, horizontal constraints. There we are. And because I do work with the grid, via grid snapping, you see the midpoint of my line is perfectly centered. I can actually do a little trick. So I will undo one step and move this a little bit to the side. I draw from the Z line or the axis, actually a line, and snap it to the midpoint. And now the trick is the starting point, which is perfectly lined up on the Z axis, I lock, and this one I set vertical. Now when I set this to 60 or 80, you can see how the rectangle adjusts nicely. Okay, so the dimensions are okay. We can bring this up. Very good. There we are. And at this point, we can exit the sketch, go to transform and move, bring this over to here, transform and scale. We can scale this up a little bit. I don't have to scale this up so it is to scale, because the sketch properly isn't really to scale. This is all more proportionally. But I want it to be big enough so I can read it, but small enough also that when I model actually on my design, I don't always have to zoom in and zoom out. Very good. And this is the end of part 1, how to quickly create a sketch, add all the needed information, and then bring this over into Shapr, try to set up our environment correctly, scale the image to the size it's going to be useful. And then in part 2, we will take a look at how, again, while meeting with a client, we could very quickly create a 3D model. It's all about working fast and effective. Welcome to part 2 of the video, how to design a water toy with concepts while sketching, and then in Shapr3D, still sketching, but just in 3-dimensional space. For me as an industrial designer, hand sketching and computer-aided modeling, no, this is both the same. It's just 2D sketching and 3D sketching. And in this video, part 2, now I will show you the process whilst again simulating a meeting with the client, how under the time constraint we have, very quickly we could block out the basic shapes and discuss functionality so that we can capture all the ideas and wishes the client has, and then refine the design, test it, 3D print, prototype it, and then send it over for refinement for manufacturing. We will end actually just with a concept model. So let's get started. Again, our unit system is all set. All our snapping options are turned on. Our initial block out for the main body, a few lines are there. So this helped us to adjust the scale of the image. So it should be 80 millimeters wide, 50 millimeters high, and there's a little arc at the bottom. So this is something I will do first. I will bring this down maybe to here, and let's see. So 45, this looks good. 45, I do it this way. This line I would like to be the same height or length like this one. I could give this a dimension, but instead I select both lines and give this the equal constraint. This way, you see, they adjust equally. Now to draw the arc in there, we can go to the line type, either use automatic or use the arc based on your preference, and then draw an arc out. Now, when I move this up and down, you see what happens. This is actually not really what I want. So here, this midpoint, I will lock. So this line cannot move up anymore. And now I can move this up and down. But I want that this arc stops actually right there. So how do I do this? Here's another really simple trick. I will draw from here a line to there. So this is actually 30 millimeters. Okay, so important to keep that in mind. I will lock the starting point. This is also on the grid under the z-axis. The line I will make vertical. So this point I can only move up or down, and then I snap it onto the arc. And now I set this to 30. There, perfect. So you see now I have an arc that perfectly fits into a 5 millimeter distance. This line now I can delete. I really don't need it anymore. Because we actually later at the bottom will make another revolve object, I will keep it in case we would remove it. And to make sure the arc doesn't change, we could give the arc now a dimension 2. So just so you understand the options you have. Okay, very good. So we take a look at the sketch. Now we want to break elements down really easy. So we have our blue main body done. At the bottom, there's a small socket, 18 millimeters in diameter. So let's do that. This is actually an arced surface, which might make this a little bit tricky. So what would be the best way? I want to create a nice cylinder. So we'll draw a line, draw a line, draw a line. From here to here, what is the height? This is 10 millimeters, so a centimeter. And this, now we can think about it. Is this good? Yeah, 10 millimeters looks good. Very nice. The distance, this should be 18. So here the radius has to be 9. So here and here, there we can make a revolve object. Very nice. This is too short, I know. Well, we simply bring this up, and there's actually our socket. And it goes into the main volume. I try to overbuild. You will hear me saying this overbuild multiple times. Okay, so this is actually good. From the side, the blue main body is 30 millimeters. Okay, so I can give this 50 millimeters one direction. You see it does a cut, which is not what I want. So I say new body, and then I go to the bottom, change the dimension to 30. You see how I nicely modeled from the center one way and other way to do this nice and symmetrical. Those two objects I can now select and union. So they're one piece. Very good. This also makes it easier, for example, to only have one object we need to turn off. So let's take a look at the ears. How can we do the ears? There's actually an interesting problem to solve that shows you also how then direct modeling and sketching can be very effective. I will draw here a line. I don't know how long this line will be. This line will be horizontal. And then I would like to have an arc on it. There's my arc. To make the arc perpendicular to both lines, the arc center point, I line up with this line at this bottom there, because now I can select this and do a revolve. Looks good. And then there we see, ooh, this is way, way too big. So at one point we will round actually these corners, 5 millimeter and 2 millimeter, here 2. Okay, so we have to make this smaller. So 6, maybe we would like to also have another ring that goes around. What about 5, 4, minus 8. This is too small. Okay, we can keep it at this for the moment. Good. Little tip for those who are not familiar with it, I filleted these corners here. I can select all these fillets and delete them. Then I have my original object back. And I hope you notice how I'm blocking out just only the basic elements and start playing and adjusting geometry and sketches. Now this is where, or this comes back to when I said don't try to work too precise from the beginning, because things might change and evolve while we start modeling something. So here I can make this a tick even smaller. So what is the radius? This is now 10, 9.5. This looks good. So double click, we delete this, and here, this is now the dome I want, 9.5. And again, all these things can change afterwards. I would like to have a small ring that goes around it. So here is my arc. Also here, same trick. I move this center point to there, because this will be kind of like center of rotation, and there too. This one. Based on how I slide this up, I can adjust this to make things a little bit easier. I think, yeah, this is becoming actually, as you can see, this becomes convex. This is not, no, concave, this is not good. So at this point, we want a little bit here. So right there, you see, we're not creating a cave-like object. This is important for injection molding. And maybe here, actually, we do the same. I saw that. So at this point, we simply move to there. Okay, good, nice. Now these shapes I can select. Also revolve. There we are. Let's take a look at all the objects. I will round this one more time to see, do I have enough space? I do. This is all good. Beautiful. Very nice. I will hide this. I will call this front profile. So I know what the sketch really is about. Here is another trick I do. I overbuild. And you see I'm adjusting the shapes a little bit. So when we put the sphere in there, you see that it actually, the volumes intersect nicely. Overbuilding always helps because we don't have two volumes sitting next to each other, but two volumes or multiple volumes overlap. It always helps literally every program. It's just a mathematical precision problem to much easier identify how these volumes intersect. And we want them to intersect. So in this case, we can calculate the volume. So it's just one piece. Pretty nice. Okay, good. This object should be on the other side. With the pencil double tap, then we go to this view, more, mirror, simply tap on the grid, click done, and there's the other part. Pretty cool. At this point, we can also join all these three together. Good. Let's go to a front view. We have a small extrusion there on top. So here is the top face. I will click this offset edge loop and do a 5mm offset. So I'm going to do 5mm here and then 2mm for this. How does this look? Okay, this was actually the incorrect setup. This has to be 2. Okay. Interesting. Now you see when I created the sketch, that actually created a problem. So the sketch here I created on top of the face, I did too early. At this point, I have to go ahead and round these corners. Very nice. And then I round these corners. Good, because now I have a smaller rectangle or smaller surface. This one now I can more easily offset. I go by 2mm. All this can later be, again, adjusted. And then we extrude this 5mm out. Very good. Cool. So we would like to have a 20mm socket on top. Do we actually have enough material? When we select these two edges, 22. So it just actually fits onto it. Okay. Very nice. We can show our initial sketch here again. This line here, I would like to be visible in my sketch. So I select this line and then I go to more project, tap on the grid, and this will project the line into my sketch. There we see it. And now it's very easy. We set 5mm, it goes up, and it should be 20mm. Careful about snapping to your midpoint, horizontal, vertical. Oh, this one line moved up, which we projected, so let's lock it. This should be 5. This should be 10. There we are. Then also here, a small, sorry, wrong command, a small revolve. Very good. To make this intersect nicely, I overbuild, and then we join all those actually together. Union. Good. Now I have actually here really nice round corners, and here this is kind of sharp. I would like to round this actually better. So yeah, how can we do this? Let me show you something. So this is 5. When we do 5 here, this is way too much. Well, what about 2.5? Let's do the same here. Very good. And then these we can round with 1mm, but then we get very close to where the cylinder is. So that's not good. Yeah, what do we do? What do we do now? Super easy. Let's make this wider. 23. Okay. 24. So you see, I'm just pushing this over 1mm each side. And the fillet actually moves with it. There. And now I can go ahead and round these corners easily. And there I have enough flash. Pretty cool. Brilliant. So we have to do the funnel. Okay. 15 from the socket up, and 20 is then the big part. From here I need to draw somewhere an ellipse, but I don't have there something to draw on. So I select this top face, go to offset plane, 15 and 20 makes 35mm. There we are. There's my new construction plane. I can select it with a finger double tap, go to the top view, go to ellipse, and from the center, draw myself this. The center should be locked so it doesn't move. 40 is good. And 20 is also good. Very nice. This plane we created, we don't need anymore. Because if this has to actually move up or down, we could simply go to transform and select it and move this up or down as needed. And if I want to look onto the sketch, I select it with a finger double tap. Now I'm back. The grid is back aligned at the sketch, as you can see. Okay, so this goes down 20 millimeter. Very good. And then down there we have a small socket. And I'm going to build the socket this way. So revolve. So this is 10, meaning this is a 20 diameter. So when we set this to 9, then this is 18 diameter. That's exactly what I want. This has to go up maybe by another 5 millimeters. So we make this 10. Very good. So you see 5, 5, 5, like I have on my sketch there. And select this face, and then we loft it. Let's go to the top view. You see these white points here. We want them to be like as they are. If they're not, then we're actually twisting the loft, which is not really what we want. There, very good. Nice. Then double tap, double tap, double tap, and union join. Pretty cool. This is a really sharp edge. Let's round this 5 millimeter again. We use nice and even values. Very good. This one we can actually make smaller. And we can actually even remove the smaller fillet. Good. We call this actually our funnel. And wait, this was incorrect. Oh yeah, this is the funnel. And we could keep the sketch, let's say top extrusion. There we are. This is just body. So now when you book with a client, or other way around, the client books you, you're not sitting there for 10 minutes. Now you budget an hour, 2 hours for discussions, draw up ideas, etc. I'm also explaining this. So this is the reason why the video takes a little bit longer. In real life, this would actually be much faster. Very good. So let's see. Yep, it intersects perfectly. We will actually later have to adjust this because this should not be 18 when we might want to have a 2 millimeter offset. I think here we can select this and say 8. Then you see how this shrinks more. Okay. More to that just in a moment. So we have actually all these details done now. Let's take a look at how we can chord out before we move ahead, because the eyes will actually be a little bit more complicated. I will select both sides and then select shell. And this should be 2 millimeters. Nice and thick so it doesn't break. We can round these corners so they're nice and soft. Very good. Go to here, and here we do the same. Inflow and outflow. Shell, 2 millimeters. 1 millimeter. Okay, let's see where the problem is. Okay. Let's actually go to this view. So maybe some of the fillets were a problem. This is actually a nice and solid object. Shelling, as simple as it sounds, sometimes can be a little bit tricky. Okay, so you see this value actually worked out well. 0.5. There it goes bigger, and 1. Okay, then there it has a problem. So because this is a symmetrical object, I will actually do this trick. Bring this over. There we are. Select this. Extrude this up as a new body. There we are. and then extrude this one down. And from this, I would like this volume to be removed, because what I would like to check now is, hey, can I actually shell this one? And also there, we see there's one problem. Okay. So let's see, when I start removing features, can this actually help? Okay, there's a problem. Let's delete this one more time. And shell. So these two sockets actually I removed didn't really do it. What about those objects here? I removed both just to make sure they are not maybe the offender. Okay, there. So something with these shapes I created does actually have this problem. Okay, so this is not really that much of an issue. We can select this shape here, and then we go to mirror. I select this shape, or this face, sorry, done. Select both, and then we just join them back together. So now we have actually our original object back. The sketch I can delete. And we need now to figure out, okay, so something in the sketch that we created didn't really sit well. So let's investigate. Number one, and join, and then let's quickly do a shell. Okay, so that worked. So this means this this object we extruded is not the problem. Good. I can do a mirroring, and if I want, 1, 2, and 3, join them together. And now I can see, okay, both openings and shell, 2 millimeters. Good. Very good. So I have the feeling that what I set up here with one of these shapes here, they are actually causing the problem. Let's join this. I'm not overbuilding on purpose. Curious actually if what I did there, how I manipulated the geometry, if that was actually indeed what caused the problem. So there we see. So it was not the overbuilding, but it is that shape. So let's see if this one actually causes a problem. Okay, that one is good. So let's undo the step till it is built, but not fused yet. So I will mirror this over to the other side. With the shelling, also keep one thing in mind. Once you shell, then we can't really change offset so easily, or we have to change the inside and the outside face. Okay, so this now should perfectly work. Good. Okay, very nice. So back to this object. Where and what is actually causing the problem here? I make this a little bit smaller to see if maybe this could help. I needed to undo the shelling first, sorry, that's the reason why I went back. There we are. Let's join this, there we are. Okay, so just a simple radius change. There we are. Okay, good. So I will hide this body here for a moment, make myself a new revolve object, and then this I will mirror over. And join them. Very nice. 1 and 2. Shell. Cool. Okay, so beautiful. So that is basically figured out, and now the client would like to see. So how can we actually do also the eyes? Now it should be a nice, friendly and fun toy. Let's put some eyes onto it. I will select this front face with a finger double tap so I can put the sketch right onto it. And then via the circle command, make a nice big circle and then move this around. Maybe see with the grid, do I find a good position? Make this 10 smaller. This can actually, no, I would like this to be bigger. 14. More on the top. Yeah, this is good. When I zoom in more, you see then I can move the grid finer. So here I have on top 1, 2, 3, 4. Here I have 3. So I just move this over one grid. Very good. And then just lock it. So very nice. Okay. Let's cut this through. So now there we have the opening. Cool. I am going to hide those, make myself a nice cylinder, move the cylinder up, go to a side view and mirror the cylinder over. There we are. Because then from this, I would like this cylinder to be removed. It's also useful now when we start naming our objects. There, that's our funnel. The cylinder was only a small helper. There. Yeah, this looks nice, nice and big, good eyes. There should also be a nice smile. So I can select this circle profile with a finger double tap. And you see now I'm actually sketching right on that plane again. And using the fit point curve, draw, press, go to there, draw, press, release. There's a nice smile. Cool. Okay. Then we can cut through, and this is a really big opening. A little bit of water should come through, but not really actually that much. So I would like to make this smaller, and we can add a draft. Maybe 25. That looks good. And then these sharp corners. When we make him smaller, you see how we are actually rounding the edges a little bit, but we are also limiting the opening. So either we can keep this with a smile, or could maybe not have them. Keep the rounding for the smile, or completely remove it. It's a matter of taste. Also here, if this is too big, we can adjust this later. So the faces, I move a little bit. Wow, this looks really good. So the sketch initially looked good, but then the opening was way too big. Now to be a little bit precise, obviously the sketch, here I would like the sketch to get close to it. But be careful that you do not by accident. And as you can see here, I was projecting in the edge actually. So I was just trying to see, I will simply do it this way. I bring them closer, but this is when it makes sense to turn all these snapping elements off, because now I can more easily get this closer. And I could zoom in more, get this a little bit closer. So I'm capturing the opening again via the grid. I could project this edge into the sketch, but then it's not really a 3-point fit curve anymore. So that's the reason why I did this. We can call this eyes and mouth opening. Maybe bring this down. Very good. Okay, now we need to create something that's inside the eye. On this side, we actually created the opening, so I will work now modeling the eye on the other side. We need first a construction axis, and we'll use through cone. Select, cylinder. Select the cylinder, done. Then we will add a construction plane, and will be through edge at an angle. Select this, -90, so it's horizontal. Very good. Tap this. Double tap, turn on section view. Now we can look into our object. Pretty cool. So this axis is actually useful. So I will draw myself here a line. So this axis got projected, and then I will delete this axis. Because now I have a line that is really where it needs to be. At this point I will unlock, move this one down to here. The upper one I just leave where it is. To there, lock. Okay, very good. This line I can remove. The eyes should sit inside. And now I'm going to draw only half of it. So here is my arc. But I would like this arc to be tangent to this direction. Okay, so check this out. At this point we lock. The arc to this line we make tangent. This line, however we want to be, horizontal. And there it is. Very good. The eye should rotate. So also it should be a little bit loose. What's actually this distance? This is 0.5 millimeter, way too small. So a millimeter, we give this a nice loose play. How much is this? 2 millimeter. This is fine, maybe 2 back. Then we draw this over. I'm using the grid simply to line up everything nicely. Bring this one down to there, and then say, hey, all you horizontal, vertical, what is this one? 2 millimeter is good. Very nice. This layer at one point has to sit in some sort of a socket. So here's, for example, the socket. This one here has this element, so the eye doesn't pop out. And it's rotated. There, you see how easy this is. This construction plane also we don't need anymore because we always have the sketch to go back to it. Let's give this a small rounding, maybe a millimeter, so it's nice and soft. If this is not too big of a distance, we can always adjust this in post. We want this maybe to be 0.25, round this a little bit, or 5, 0.5 millimeter. Very nice. Okay. The whole object now we have there. So this we will call this is actually eye right. It really pays off to work clean. We will call this eye profile. Very good. Yeah. And this body here I will change height. Here we have this socket, so I will revolve this a little bit. Very good. Make this a little bit bigger. And I am mirroring this over. There we are. Because the main reason for this is, here's my body. Now there you see I brought the piece in. I'm going to hide all the sketches, and then you and you join with this one. Cool. I'm already putting a little bit more detail in. This is more than something that would start to happen actually after the prototyping. Maybe we would like to have a prototype including the eyes to rotate. So we need to build in at least a little bit of geometry that actually the eye would move. So we need some sort of blades. So here is this sketch for the eye. I would like to go right onto it. So I will select the sketch profile, finger, double tap. Very good. So now I can think about it. So how do we draw this ideally? Maybe here, bring this over, bring this down. There's actually the socket. We give this a little bit of a millimeter of play. This we move down. Okay. So there's the millimeter play in between. Very nice. Then this 0.5 millimeter and a millimeter. And this one, 21. I make a tick wider. This actually went way too far. 20. Yeah, 20 is fine. Very good. Very nice. So if I have my eye here, there you can see where this would be. Now we need to have more of those. Move the 3D widget to the center of the cylinder, 180 for the rotation, double tap both, and now we could say 90. Select all those. Copy 45 degrees. There we are. Cool. So you see it's actually not really that complicated. And we can quickly in the outliner select all those objects and join them together. There we are. Very nice. Select this eye, go to a side view, mirror. We want to mirror this over. So what's important now is this has to be rotated because the blades are connecting each or intersecting. So 45 divided by 2 is 22.25. There, for example. Or who knows really how much this really has to be. This is all based on something later to point out because the water actually will move these blades. I don't know, so maybe I set this at this rotation. So looks nearly complete. Before we can add colors, we need to add something for the eyes. So how do we do the eyes? It's actually easy. Add construction plane from this flat surface. We simply add a plane up. On this plane, double tap, and then let's create the eye detail. So there, copy, simply move this over, and via the grid, I line this up. There we are. This construction plane I delete. Eye points. And this ring I will project onto that surface. And this ring I project onto that surface. Very good. Last thing now, very quickly, and we can talk with the client, colors. So we make this orange. Very nice. And blue should be the whole body. And white should be the eyes. And black here, these dots. But orange, I would like those elements to be. Yeah, very good. And there we are. So this is now something that could be 3D printed as one. Maybe we actually have to slice this into 2 parts and then put keys into it. And this is then something that would actually happen in the refinement stage. But you can see how quickly after the initial sketch, we then created a somewhat functional prototype that is useful enough to talk about the client if and how this works. For example, I just discovered right now, hey, yeah, those have to be actually moved back. So I made those hilariously too big. So maybe just looks like I have to adjust those each one by one. So 41. Also here, I could do this with one piece, delete the other eye, copy and paste it back, recut the eye dot. And these are then the modeling mistakes you oversee, but then you discover when you start looking into the object. And as you can see, via direct modeling, this is so easy to adjust in Shapr, which is why it is such a joy to work with. And that's it.